To make it easier to locate subjects for review, we've divided this video presentation into 7 sections. First, we'll be looking at the items that are included with the machine and what equipment and supplies you'll need to provide. Next, we'll review the principles and basic theory of gas tungsten and shielded metal arc welding. In the third section, we'll discuss safe welding practices and safety equipment. In Part 4, we'll set the equipment up, first for gas tungsten and then for shielded metal arc welding. In Part 5, we'll discuss gas tungsten arc welding procedures on mild steel, stainless steel, and aluminum. In Part 6, we'll cover basic shielded metal arc welding techniques. And finally, in Part 7, we'll be discussing equipment maintenance and troubleshooting procedures. The Miller EconoTIG package includes practically everything you'll need to begin welding. Included is the welding machine itself. The TIG torch has a unique flow-through shielding gas connection. This lets you connect and remove the TIG torch without using any tools. The torch comes with a nozzle, heat shield, collet cap, 3/32 collet and collet body, and a 2% thoriated tungsten electrode. The foot control is used to remotely control the amperage when gas tungsten arc welding and has a 15-foot cable. For increased mobility, an optional current and contactor control is available that connects to the torch and is fingertip control. The argon regulator flow meter, 12.5-foot gas hose, 12-foot work cable and clamp, and stick electrode holder complete the package. For gas tungsten arc welding, you'll need to provide a cylinder of argon shielding gas. And for shielded metal arc welding, you'll need electrodes suitable for your job. In all electric arc welding processes, the heat for welding is created by an electric arc. In shielded metal arc welding, the arc is established between the end of the electrode and the base metal. The heat melts both the end of the electrode and the base metal. As the electrode melts, it flows into the molten weld joint as filler metal. In gas tungsten arc welding, an arc is maintained between the tungsten electrode and the base metal. However, the tungsten electrode is not consumed in the weld. On joints where filler metal is required, a welding filler rod is fed into the weld zone and melted with the base metal. In any type of welding, the molten weld puddle must be protected from the atmosphere. Otherwise, oxygen and nitrogen will combine with the molten weld metal and result in a weak, porous weld. In shielded metal arc welding, this is accomplished by the flux coating on the electrode, which melts and creates both a shielding gas and a slide covering for the deposited weld metal. In gas tungsten arc welding, argon, which is an inert gas, is used to shield the welding arc. When the remote control is activated, the arc is initiated, and at the same time, the gas solenoid in the welding machine opens. Gas flows from the cylinder, through the regulator flow meter, through the gas solenoid, through a hose in the torch cable assembly, and out the nozzle on the torch. When welding current is shut off with the remote control, shielding gas continues to flow for 15 seconds to cool the tungsten electrode and protect the molten weld puddle while it solidifies. Welding is safe when proper precautions and work practices are followed. However, as in most jobs, there are certain hazards you must be aware of. The safety section in the owner's manual outlines precautions that must be taken regarding electric shock, arc rays, fumes and gases, fire or explosion, flying sparks and hot metal, and proper handling and use of shielding gas cylinders. The owner's manual also has a listing of booklets available from various sources regarding safety. The welding arc supplies both heat and light to the work area. The heat is for welding. The light is only incidental. However, it can seriously damage unprotected eyes, so never look directly at a welding arc without proper eye protection. A welding helmet with a number 11 safety lens for welding on aluminum or a number 10 lens for steel or stainless steel is an absolute requirement. The darker shade lens is required for welding on aluminum because it reflects more light. Proper clothing includes a long-sleeve shirt buttoned at the collar and wrists. A leather jacket, apron, and gloves will help protect you from arc burns and radiation. Wear high-top shoes or boots and trousers without cuffs. Be sure there is adequate ventilation and that all flammable materials are removed from the welding area. Let good common sense be your guide, and be sure you read and understand all information in the safety section of the owner's manual before setting up or operating the equipment. In this section of the video, we're going to go through the steps involved in setting the equipment up for welding. First, for gas tungsten, then for shielded metal arc welding. We've placed the power source on the optional carry cart and cylinder rack. It makes it easy to move the machine. Plus, there's a cylinder rack support for the cylinder of argon shielding gas, and the bottom tray is convenient for storage. The installation procedures we're going to be covering are outlined in Section 3 of the owner's manual. To attach the work clamp, slide one of the insulating sleeves over the cable. Use the nut and bolt provided and attach the work clamp to the connector on the work cable. Bend the tabs around the work cable. And slide the insulating sleeve around the work clamp handles. You'll need to install the connectors to the TIG torch and electrode cables. Slide the handle over the torch cable. Connect the torch cable to the connector body, and then slide the handle over the connector. The electrode cable connector is assembled in much the same way. Slide the handle over the cable. Strip the cable and install the sleeve fully into the connector body. Tighten the set screw, then slide the handle over the connector. When the tungsten is secured in the torch body, it should not extend more than a ½ inch beyond the nozzle. As a general rule, start with an extension of 1 electrode diameter. Joints that make the root of the weld hard to reach will require additional extension. For gas tungsten arc welding, the weld process selector switch is placed in the GTAW position. When the switch is in this position, the remote foot or torch-mounted hand control turns on and adjusts amperage in the welding circuit. As the label indicates, the Arc Assist starting system is active when the switch is in the GTAW position. Arc Assist helps start and stabilize the arc. It does not require any adjustment. The remote control is connected to the receptacle on the front panel. Be sure that the gas cylinder is secured to the running gear. Remove the cap, stand to the side, and briefly open the valve slightly. This blows any dust or foreign material out of the fitting. Install the regulator flow meter to the cylinder so the face is vertical. Connect one end of the gas hose to the regulator flow meter and the other end to the gas fitting on the back of the machine. Make sure the fittings are tight to avoid gas leaks. The machine is now set up for gas tungsten arc welding. To set the machine up for shielded metal arc welding, the torch is removed and the electrode cable is connected to the receptacle on the front panel. For shielded metal arc welding, the process selector switch is moved to the SMAW position. When the switch is in this position, welding output goes on and off with the power switch. And amperage is controlled by the front panel amperage control. We'll be discussing the selections on the range polarity switch in the sections on gas tungsten arc and shielded metal arc welding. In this section, we'll be setting the machine up for gas tungsten arc welding, then making some welds, first on mild and stainless steel, and then on aluminum. The area where the weld is to be made must be clean, and any traces of oxide, dirt, or grease must be removed. Another source of contamination, especially with aluminum, is the filler metal. Use steel wool to remove any oxidation. The 3/32 inch 2% thoriated tungsten that's supplied with the torch can be used throughout the AC and DC range of the power source. Generally, alternating current is used when welding on aluminum, and direct current electrode negative is used when welding on steel and stainless steel. The tungsten is prepared based on the type of material being welded. Our first welds will be on steel, so we'll prepare the tungsten by grinding it to a point on a fine grit, hard abrasive wheel. Notice that the grinding marks run lengthwise with the point. This is the correct method of pointing the tip. Since we're welding on steel, the polarity switch is set to the direct current electrode negative position. The weld process switch is in the GTAW position. Open the gas valve on the cylinder and set the flow meter for approximately 20 cubic feet per hour. You may need to increase this if you're welding in a drafty area. Turn the welder on. To start the arc, position the torch in the joint area. Lower your helmet. And depress the foot pedal or rotate the torch-mounted control if you're using it. If the arc does not start, rotate the cup to move the tungsten closer to the workpiece. A brief momentary touch of the tungsten may be required. After the arc is initiated, raise the torch to the proper angle for welding. For this outside corner joint, the torch should be at about a 70-degree angle. For this joint on mild steel, filler metal is not being added. Simply controlling the amount of heat with the foot control and letting the edges melt and flow together. Looking at the finished weld, we see that the edges are fused and that the ripple patterns in the bead are uniformly spaced. On joints that require additional filler metal, such as this mild steel lap joint, establish a puddle of the desired size and begin feeding filler rod into the leading edge of the puddle. Hold the rod at approximately a 20-degree angle so that the tip is heated by the arc, but final melting and transfer of metal occur when the rod is dipped into the weld puddle. To avoid atmospheric contamination, make sure you hold the hot tip of the rod in the protective envelope of the gas shield. Hold the arc length to about 1 electrode diameter and travel at a speed that will produce a bead about 2 to 3 electrode diameters wide. To finish the weld, the torch angle may be decreased to help in filling the crater. Add enough filler metal to avoid an unfilled crater, since cracks often begin in a crater and continue through the bead. The ripples are uniformly spaced, indicating correct travel speed, and the bead is the correct width. Before welding on aluminum, we need to form a ball at the end of the tungsten electrode. This is done by striking an arc with the polarity switch in the direct current electrode positive position. This is the only time electrode positive is used while in the GTAW mode. The ball at the tip should be about 1.5 times the electrode diameter. When you're welding aluminum, watch for the puddle to become shiny, then start adding filler rod. Looking at this properly made butt weld on aluminum, we see that buildup is correct, that there is good penetration, and the bead edges are fused in. Aluminum is a very good conductor of heat, so on small pieces, the entire part may heat up to a point that requires reduction of amperage from the original setting. The foot-operated amperage control will help in the finishing of the bead, since amperage can be lowered to decrease puddle size as filler metal is added. Switching the machine over for shielded metal arc welding takes only a few moments. Disconnect the torch from the front panel and connect the electrode cable. Select the proper polarity, direct current electrode positive. Move the process selector switch to the SMAW position. Remember, when the switch is in this position, the output goes on and off with the power switch. When the switch is in the SMAW position, the remote amperage control is out of the circuit, and amperage is set with the amperage control on the front panel. 1/8" diameter E6013 electrodes are a good choice for general purpose stick welding. The electrode and amperage selection chart in the owner's manual lists the suggested amperage range for various types and sizes of electrodes. As the table suggests, the amperage range for an 1/8" E6013 electrode is 75 to 125 amps. As the chart on the machine indicates, setting the amperage control at 85% will give you approximately 100 amps in the direct current range. Put the electrode in the holder. To start the arc, drag the electrode across the workpiece as if you were striking a match. As you're making the weld, tilt the electrode about 10 to 30 degrees in the direction of travel. Maintain an arc length, that's the distance between the end of the electrode and the workpiece, equal to the electrode diameter, in this case, an 1/8". If the arc length is too short, arc voltage will be low and the electrode may freeze to the work. If arc length is too long, arc voltage will be high and excessive spatter can result, in addition to poor control of the arc. The proper arc length will give off a characteristic frying or crackling sound. Use a chipping hammer and wire brush to remove the slag from the weld. The shape of the weld ripples and the bead width are good indications of correct travel speed. A bead approximately 1.5 times the width of the electrode, which shows half-moon-shaped ripples, indicates correct travel speed. This machine is designed for light-duty operation and is rated at 150 amps for gas tungsten arc and 130 amps for shielded metal arc welding. And it has a 20% duty cycle. The duty cycle is the number of minutes in a 10-minute period that the machine can be operated at full rated output. A 20% duty cycle then means that the machine can be operated at rated output for 2 minutes out of each 10-minute period. When operating at amperages less than rated output, the duty cycle increases, so this usually isn't a limitation. In the event the transformer does overheat, however, welding output will be shut off, and the high-temperature shutdown light will come on, and the fan will continue to run. When the light goes off, you can resume welding. There's some routine maintenance procedures that are performed each 3 months. Be sure that the power source has been turned off and the input power disconnected before inspecting, maintaining, or servicing the machine. Any damaged cable should be taped or replaced. Check to see that all labels are readable. If not, they should be replaced. Check the O-ring at the torch receptacle. If it's cracked, it should be replaced. At the same time, inspect the torch body, torch cable, and gas hose. Damaged or badly worn parts should be repaired or replaced. Each 6 months, remove the wrapper and blow out or vacuum dust and dirt from the interior of the machine. If you're having a problem starting the arc, check that all connections have been made. Remember that the welding circuit must be complete and all connections properly made. If porosity is a problem, first check to ensure that the material was properly cleaned before welding. Then check the shielding gas supply to be sure that there is gas in the cylinder, that the flow rate is set correctly, and that all gas hose connections are secure. If the arc seems different than usual, check to see that the polarity switch is in the correct position. TIG welding is probably the most difficult welding to master and will require many hours of practice to become proficient. Remember, proper cleaning of the workpieces prior to welding is essential if welds of cleaning with a chemical solvent is usually sufficient. Be sure you completely remove all oxide, oil, grease, and other foreign material from the work. Remember that the information presented in this videotape is designed to supplement the owner's manual. Follow all in the owner's manual, particularly in the safety section. Refer to the illustrations in the owner's for help in solving related welding. Remember that your welding distributor is ready to assist you and provide technical information should you have a problem.